Hey, Algebra 1A people, Mr. Hayward here. Today we're doing 5.3. We're going to do the notes, so that's the odds. Only 6 of them, nothing too crazy. We are talking about solving systems by elimination. Now, we've done solving systems by graphing and solving systems by substitution. Now, graphing, just as a small recap, we graphed them, saw where they touched. Okay? Substitution, that's when we had a y equals or an x equals and we actually substituted it in. Now the last way that we are going to look at is called by elimination. Okay, now let's look at number 1, and I'm going to talk to you really quick about why I would not want to do the other two. First of all, graphing is usually people's least favorite because you have to have graph paper and laziness and all those other things. But number 1, you should also notice both of these equations are in standard form. Something with an x, something with a y equals something without a variable. That's standard form. ax plus by equals c. Standard form sucks to graph because you actually have to change it into slope-intercept form. Okay? Now, really quick, what if we tried to, I'm just going to show you on the bottom equation, if you did try to change this into slope-intercept form, you would get y equals 2/5 x plus 17 over 5. And then you'd have to graph that. That sucks. Just saying. Okay? So that's why I don't think graphing would be great. Next, we learned about substitution. Well, substitution, you need something that says y equals or x equals. Now, originally, I didn't give you anything that says y equals or x equals. So you would have to change them into something that says y equals or x equals. But notice, even here, when I changed this into something that said y equals, it still sucks. So, can you do this by graphing or substitution? Yes. Is it going to suck? Yes. So let me teach you a third way called elimination, okay? Ignore all this. All right, I'm going to do something weird here. Now, the thing that I'm going to do that's weird actually is really nice when they're both in standard form. I'm going to draw a line. It's not the weird part. Maybe. I don't know. How often do I draw lines? Probably a lot. Oh, yeah, because I talk about how awesomely straight they are. Look at that line. That's nice. Anyways, here's the weird part. I'm going to take these two equations and I'm going to add them together. Sorry, wait, what? Yeah, I'm going to take these two equations and I'm going to add them together. Just straight down the line. Now, some of you might say, Mr. Hayward, can you do that? Does that break the laws of math? Okay, maybe you didn't say that, but let's ask that question anyways. Can I add two equations together? Well, let's look at it this way. If I look at it as like the top equation, what am I doing to the top equation? On the left-hand side, I'm adding negative 2x plus 5y. On the right-hand side, I'm adding 17. And you might cry out, Mr. Hayward, you are supposed to treat both sides equally, to which I would point out those two things are, in fact, equal. So can I do this? Yes. Now, watch what happens. Let's start from the right-hand side. Negative 22 plus 17. Squish those together, you are going to get a negative 5. Okay, nothing too crazy. Negative 6y plus 5. I can squish those together because they both have y's, and I get a negative 1y. 2x minus 2x. You squish those together, and they, whoa, go away. Or they are eliminated, hence the word elimination. The whole purpose of elimination is to add the two equations together so that one variable goes away. Dude, look at this. I'm left with a one-step equation. If I divide by negative 1, I get y equals 5. Heck yeah. But don't stop there. If you say y equals 5, that's my answer, I'm going to say, sweet, graph that. And you're going to say, wait, what? Because remember, when you solve systems, you're trying to find out where they would touch if you graphed them. This is half of your answer. Half. You need the x value, which you can get by plugging it in. It doesn't matter if you plug it into the top equation or the bottom equation. Just for fun, I am going to plug it into the top equation. 2x minus 6y equals negative 22, but we just found out y equals 5, so I plug that in. 2x minus 30 equals negative 22. That gives me a two-step equation that I can solve. If I add 30, I get 2x equals 8. When I divide by 2, I get the other half of my answer, x equals 4. Done. Recap. I added them together. That gave me half of my answer. Plug that back in to find the other half. That last part should sound very familiar. When we did substitution stuff, the last step said take that variable and plug it back in to find the other variable. That's it. Right? All right, look at number 3. Let's do the same thing we did before. Let's ignore this little x equals 4 here. We don't need that for this problem. All right, I'm going to add my two equations just like I did before. Let's start from the right-hand side. 20 and a negative 20. Oh, shoot, those go away. Well, technically they don't go away. They add to 0, which you can put if need be. Since there's nothing else here, put a 0. Okay, well, move on. 4y minus 4y. Well, shoot, that goes away too. 2x minus 2x goes away too. 0 equals 0. Have we seen that before? You should say yes. We've talked about two different special cases. One special case was when we graphed it, they were parallel and there was no solution. The other special case is when we graphed it, their lines were on top of each other. Now, I think we did a problem like if you go back to 5.2, number 9, when you ended with a true statement, no variables, but a true statement, your answer was an infinite amount of solutions. I ended with no variables and a true statement, so my answer is infinite amount of solutions. Don't forget, sometimes it's called infinitely many solutions or infinitely many amounts of solutions. It almost always says infinite something solutions, okay? That's it. Now look at how much work I didn't have to do here. I added everything together. I got 0 equals 0. Boom. Done. Okay. Look at number 5. Now, sorry, number 5's going to have an answer. It's not as quick and simple as the other one. Okay? Now, if I come right here and I add these two things together, just like I did before, golly gee, this is great. We're getting the hang of this. Negative 26 minus 21 gives me a negative 47. Heck yeah. Okay? Negative 8y gives me a negative 16y. Okay? 6x, 7x gives me a 13x. Great. Wait. Nothing canceled. Shoot dang. Did we do something wrong? Yes. We have a couple options here. You can try and give up. Not recommended. Or you can use your sick algebra skills to do some manipulation. What if I took this top equation? I'm going to do something else weird. I'm going to multiply this entire top equation by negative 1. It means I'm going to take negative 1. I'm going to multiply by every term. Negative 1 times 6x is a negative 6x. Negative 1 times negative 8y is positive 8y. Negative 1 times negative 26 is 26. I wrote 22. What am I doing with my life? Now, I am going to ignore that equation, and I'm going to proceed as if this, what I'm staring at right now, were my original problem. Here's what I did in layman's terms. I didn't see two things that were going to cancel out. For instance, like in number 1, 2x minus 2x, those canceled out. In number 3, 2x minus 2x, or 4y minus 4y, those canceled out. Now, those have a name. They're called opposites. Opposites will cancel out and make a 0. Well, for 5, I didn't have opposites, so I made opposites by multiplying an equation by something very specific. I could see here, this says negative 8y, negative 8y. Well, if that were just a positive, then it would say negative 8y and positive 8y. Those are opposites. So I multiplied, and I made opposites. Now watch what happens when I add them together. Well, negative 21 and a positive 26 gives me 5. My two opposites now cancel out. Heck yeah. 7x minus 6x is x. Golly gee, look at that. Now don't say that's my answer. because you're half right. Oh, you're halfway there. No, you have half of the answer. You need the other half. Now I'm going to take 5 and I'm going to plug it back in. Trick question. How many places do I have that I could plug 5 back in? You should say 2. No, wrong. 3. My original 2 equations, or if I wanted to, I could plug it back into the new equation that I made. Do I need to? No, but those are all my options. Just for fun, let's plug it into the top one. 6x minus 8y equals negative 26. And then we solve. 30 minus 8y equals negative 26. And then we solve. This is a 2-step equation. I'm hoping you all can do 2-step equations in your sleep. I mean, I'm hoping you're not sleeping right now, but like if you were sleeping, I think you could do the... Okay, anyways. Negative 26 minus 30 is negative 56. And then when I divide by negative 8, running out of room, I get y equals a positive 7. Double check my math. Do it. Done. Okay, keep going. Look at number 7 on the back. Okay, so I'm going to now be aware that I'm not always given opposites. Like in problems 1 and 3, I had opposites ready to go. You could just add the 2 equations together. Boom, done. It does not always work that way. Okay. Now in this one, do I have opposites? 10x and negative 3x, not opposites. 12y and negative 6y, not opposites. I don't care about these yet because they don't have variables. Shoot. How can I make opposites? Well, 6, that's only half of 12. So what if I just doubled it? Can you do that? Yes, you can. I'm going to multiply the entire bottom equation by 2. Look at what I do here. I'm not going to touch the top equation. 10x plus 12y equals 8. That equation's looking nice. But the bottom equation, on the other hand, I'm going to take this 2, and I'm going to multiply by every term. Biggest mistake I see here is people forgetting to multiply 2 by every term. 2 times that negative 6y gives me a negative 12y. Now look it, before I do anything else, those are my opposites. So eventually I'm going to add these and these are going to go away. But don't forget, multiply everything by 2. 2 times a negative 3x is a negative 6x. 2 times 12 is 24. Now I am going to add these equations together now that I know I have opposites. Okay? 10x minus 6x is 4x. 8 plus 24 is 32. Now, if you do this right, if you don't have a special case after you add your equations together, you should always have a one-step equation. Always. We can do one-step equations. Left-handed with our eyes closed. Maybe you are left-handed. Off-handed with your eyes closed, hopping on one foot, you should be able to do one-step equations. Just saying, we spent like 2 years on it. Now again, that's half my answer. I'm going to take 8, I'm going to plug it in. I could do either of these two, or I could do this new equation I made. 10x plus 12y equals 8, that's the same things here. So I have 3 options again. It doesn't matter, I'm going to plug it into this top one here. 10x plus 12y equals 8. Probably not the best choice. You probably should have picked the one with smaller numbers, but hey, we're going to go with it. So 80 plus 12y equals 8. 2-step equation. Subtract 80, and I get 12y equals negative 72. And then when I divide by 12, I get y equals a negative 6. If you had plugged 8 into either of the other equations, you still should have gotten negative 6. Okay? So we looked for opposites. We didn't see them, so we made opposites, added it together for half the answer, plugged that back in for the other half. We getting the hang of it yet? We having fun yet? I am. Okay, so look here. Negative 12x minus 6y equals 18. And 3x plus 2y equals a negative 8. Okay, now, some of you are hopefully saying, well, we don't have opposites. Then those of you who are saying we don't have opposites, hopefully you're trying to find a way to make opposites. Now, some of you are looking at the x's, and you're saying, what if we took 3 and we multiplied it by 4? So if we multiply the entire bottom equation by 4, it would be a positive 12x. So negative 12x, positive 12x, those would cancel. Sweet. Some others are looking at the y's and saying, well, what if we multiplied the entire bottom equation by 3? That would make this a 6y. Negative 6y, positive 6y, gonna cancel out. Awesome. Do you know which way would work? Both. It does not matter which of those you choose. In fact, technically there's an infinite amount of ways to manipulate this to have opposites. Personally, I like the second approach where I multiply the bottom equation by 3, only because it's a smaller number. I would have to multiply that by 4, bigger number. So I'm going to keep my top equation, negative 12x minus 6y equals 18, and I'm going to take this entire bottom equation and I'm going to multiply by 3. 3 times 3x is 9x. 3 times 2y is 6y. And 3 times negative 8 is negative 24. Notice I kept my equal sign in the exact same spot. Now I've got a negative 6y and a positive 6y. Those are opposites and are therefore going to go away. Negative 12x plus 9x is a negative 3x. And then 18 minus 24, what is that? Negative 6. One-step equation? Heck yeah. Divide by negative 3, and I get half my answer is x equals 2. Don't stop there. You're going to take that and you're going to plug it back in. It does not matter where. You could plug it into the top, the bottom, the new equation. Here's my recommendation. Look for the smallest numbers. Look at this equation right there. Looks like it's got some tiny numbers. So 3 times x plus 2y equals negative 8. That is manageable. 3 times 2 is 6. And now I've got a two-step equation. If I subtract 6, I get 2y equals negative 14. And when I divide by 2, I get y equals negative 7. That is the other half of my answer. So if I were to have graphed the two original equations, they would cross at 2 comma negative 7. Done. All right, one more. All right, now you're looking at this, probably thinking, yeah, we don't have opposites. Maybe trying to rack your brain and figure out a way to make opposites, and that way might not be coming to you, because this problem sucks. It's a little bit more difficult, because I can't just double 1 or multiply by 3 or 4. So let me give you a way that works 100% of the time. Let's say you're looking for opposites, you can't find them, and you cannot think of a quick and easy way to make them. So what you're going to do, you're going to put parentheses around both equations. I'm actually going to multiply both equations by something. Now, I'm going to look at the x's or the y's, and I'm going to pick the smaller numbers. So 18 and 12, or 9 and 6. Okay, 9 and 6, those are smaller numbers. I'm going to switch them. Ignore the negative. 9 on top, I'm going to multiply the bottom equation by 9. There's a 6 on bottom. I'm going to multiply the top equation by 6. Notice, I took those two numbers, 6 and 9, and I flipped them. Now here's why. I'm going to ignore the first and the last term. I'm just going to look at the middle term. Negative 9y times 6 is a negative 54y. Positive 9, or excuse me, 6y times positive 9 is a positive 54y. Notice just that switching of it gave me opposites. So I have a negative 54y and a positive 54y. Those are going to cancel out. But don't forget, you've got to multiply everything by 6 here. So you'd also have to say 6 times 18x. Don't freak out just because it's kind of a large number. You've got calculators. Then 6 times 20. Okay, let's ignore this problem for a second, okay? Same thing on the bottom. I'm multiplying everything by 9. So 9 times a negative 12x is a negative 108x. Then 9 times negative 12 is negative 108. All right, so now we're looking at this problem. Sweet. Starting from the right, 120 minus 108 is 12. Now, just like we wanted before, these two are opposites and they cancel out. And then we come over here. Oh, hey, these two are opposites as well. 0 equals 12. Did we do something wrong? No. You should remember our other special case, when you end with no variables but a false statement. That means your answer is no solution. In other words, if I were to graph these two equations, I would actually find that they are parallel. They never touch at all. Okay, quick recap of elimination. When solving a system by elimination, you want to first make sure you have opposites. If you don't have them, you've got to create them by multiplying. But once you have opposites, you're going to add them together and solve for one variable. Plug that back in for the other variable. You're going to write your answer and then go, smiley face. Done. All right, I still miss you all. We will do our practice on Wednesday. Good luck, and see you soon.